The dream of creating intelligent machines is as old as human civilization, appearing in ancient myths about automatons and golems. However, the scientific pursuit of artificial intelligence, or AI, truly began in the mid-20th century, fueled by the invention of the electronic computer. The core idea was simple yet revolutionary. Could machines not just calculate but think? This question laid the groundwork for one of humanity's most ambitious technological quests, moving from the realm of science fiction into serious academic and engineering challenges. Many brilliant minds contributed to AI's genesis, but Alan Turing, a British mathematician, is widely considered one of its very first and most profound innovators. In his groundbreaking 1950 paper, Computing Machinery and Intelligence, Turing explored the concept of machine intelligence and proposed what became known as the Turing Test. He imagined a scenario where a human judge would converse with both a human and a machine without knowing which was which. If the judge couldn't tell the difference, the machine could be said to exhibit intelligence. This wasn't about a physical look for AI, but a conceptual framework for how it could work and be identified, originating from the United Kingdom. The term artificial intelligence itself was coined in 1956 at a summer workshop held at Dartmouth College in the USA, organized by John McCarthy. This event is often seen as the official birth date of AI as a field of study. Early AI systems, though rudimentary, began to emerge. Programs like the Logic Theorist, developed by Alan Newell, J.C. Shaw, and Herbert Simon, could prove mathematical theorems. Another famous example was ELIZA, created by Joseph Weizenbaum, which simulated conversation by identifying keywords and responding with pre-programmed phrases, surprisingly convincing some users it was a human. These early AIs generally looked like lines of code running on large room-sized mainframe computers. They worked by following step-by-step rules and logic to solve specific, narrow problems. Despite these early successes and a wave of enthusiasm, the complexity of real-world problems soon became apparent. Early AI programs were often brittle. They excelled at the specific tasks they were designed for, but struggled with common sense or tasks outside their narrow domain. Computers also lacked the processing power and data storage we have today. This period from the mid-1970s to the mid-1980s is often referred to as an AI winter, as funding dried up and public interest waned due to unfulfilled promises and the sheer difficulty of making machines truly intelligent. However, AI never truly disappeared. The late 1980s and 1990s saw a resurgence, particularly with the rise of expert systems which captured human knowledge in specific domains like medical diagnosis using if-then rules. More importantly, the focus began to shift from purely rule-based systems to machine learning, where algorithms learned patterns from data rather than being explicitly programmed for every scenario. Early forms of neural networks, inspired by the human brain, also started to gain traction again, benefiting from slow but steady improvements in computing power and new learning algorithms. Today, AI is experiencing an unprecedented boom, largely thanks to advancements in deep learning, a specialized form of machine learning using very deep neural networks. The key ingredients for this revolution are massive amounts of data, big data, powerful graphics processing units, GPUs for complex computations, and sophisticated algorithms. Modern AI is everywhere, powering facial recognition, voice assistants, recommendation systems, self-driving cars, and even generating creative content like images and text. These systems are no longer just lines of code. They are complex models that learn and adapt, continuously evolving to tackle increasingly sophisticated challenges, truly bringing the dream of intelligent machines closer to reality. Subscribe to @Organic Innovator for more professional, well-researched content and tutorials in science, innovations, and technology.